Hello everyone, welcome to the channel Anka Ananda Aharan, that is extracting happiness from the teaching learning process of mathematics. Today we are going to discuss one of the important aspect of eigenvalues and eigenvector chapter, that is chapter 5. The topic is diagonalization. So before going to diagonalization, we should know what type of matrices can be diagonalized. To know that, we must know what do we mean by algebraic multiplicity. The algebraic multiplicity of an eigenvalue of a matrix is the number of times it occurs or repeats in its characteristic equation. For example, suppose the characteristic equation of a matrix is 3 lambda minus 2 7 is equal to 0. So here lambda is equal to 5 has algebraic multiplicity 3 and lambda is equal to 2 has algebraic multiplicity 7. So number of times it occurs in its characteristic equation is the algebraic multiplicity. Now what is geometric multiplicity? For a is equal to lambda is equal to lambda I minus this. A minus lambda I has how many linearly independent x satisfying this equation a minus lambda I is equal to 0. How many linearly independent non-zero vectors occur corresponding to lambda is equal to lambda I? That is the geometric multiplicity. We must know that algebraic multiplicity is always greater or equal to geometric multiplicity. And if any number is having algebraic multiplicity 1, then its geometric multiplicity is also 1. Means for distinct eigenvalues, the corresponding geometric multiplicity and algebraic multiplicities are same. Now, what do we mean by defect of an eigenvalue? It is the difference between algebraic multiplicity to geometric multiplicity. If it is non-zero, if defect of every eigenvalue of a matrix A is 0, then the matrix can be diagonalized. If the defect of any eigenvalue is non-zero, then the matrix cannot be diagonalized. So, what is the meaning of defect non-zero? If diagonalization, a matrix is defect is 0. A matrix with 0 defect is a diagonalizable matrix. Now, what do we mean by 0 defect? The number of eigenvalues A has, suppose it is repeated, no issue. How many times it is repeated, that is not the issue. Total number of eigenvalues and total number of linearly independent eigenvectors, if they are same, then the defect is 0. In that case, the matrix can be diagonalized. Suppose that means there exists a situation where a matrix having eigenvalue is lambda is equal to 2. 2 is repeated for 3 times. Sorry, 3 times. But A minus, suppose it is lambda 1. But A minus lambda 1 I x is equal to 0. Suppose it has only 2 linearly independent vectors or 1 linearly independent vector. Then this matrix cannot be diagonalized. If number of linearly independent eigenvectors and total number of eigenvalues they are same, then the matrix can be diagonalized. Consider a matrix which can be diagonalized. Then how to diagonalize it? It is find out the eigenvalues and the corresponding eigenvectors of A. Then if the number of eigenvalues and number of linearly independent eigenvectors are same, then we have to write X, H, S, H, the eigenvectors as its column, a matrix with eigenvectors as its column, and we will find out S inverse. Then we will multiply S inverse AS, and to get lambda, what is the formula for lambda? S inverse AS. This is the formula for lambda. We will get a diagonal matrix, And here the first eigenvalue will be 1 position kept. Second eigenvalue will be into 2 position. Likewise, this will be having nth eigenvalue at the nth one n cross n position, that is nth row, nth column position. Rest all elements in the matrix will be 0. Such a matrix is said to be diagonal matrix or spectral matrix of the given matrix A. So here the largest absolute value of the eigenvalues is called spectral radius. And any word related to spectrum means it is related to eigenvalues. Set of all eigenvalues of a given matrix is said to be spectrum. Spectrum means set of all eigenvalues of a given matrix. Spectral radius means the absolute value of the mod of maximum of mod of all the eigenvalues of a given matrix. Now, how to find out a given matrix A from its eigenvalues and eigenvectors? From the eigenvectors, make columns from the given eigenvectors, making the columns of a matrix, we will form a matrix S. And from the S, we'll find out S inverse. Then S inverse lambda, S inverse S lambda S inverse will give us the matrix A. So here what is S? S is a matrix with the n given eigenvectors as its columns, linearly independent eigenvectors as its columns, and lambda be the diagonal matrix where the diagonal elements are the sequentially arranged eigenvalues. S inverse is the inverse of S. Substituting here in this formula, we will get our A obtained. Once our A is obtained, we can comfortably find out A to the power K. So how to find out A to the power K? It is S lambda to the power K S inverse. And what is lambda to the power K? Lambda is a diagonal matrix. Lambda to the power K means each of the diagonal element will be raised to the power K. So already we have S with the eigenvectors as its columns. Then we have the diagonal matrix with the lambda to the power K, that is with lambda 1 to the power K, lambda 2 to the power K, and lambda n to the power K as its eigenvalues. Then we will go to the matrix, that is A to the power K is equal to S lambda to the power K S inverse. We have to multiply these three matrices to get our A to the power K. It is one of the easiest way to find out any power of a given matrix comfortably. If the matrix is diagonalizable, then it can be very comfortably achieved. Now let us do some of the problems. Using these concepts, whatever we have discussed. Consider a matrix A with A is equal to 1, 1, 1, 1. Let us find out this factorization of A. First we have to find out the eigenvalues. For eigenvalues solution, for eigenvalues, I require the EIGEN values. We require the characteristic equation. What is that? Lambda square minus trace of A into lambda plus determinant of A equal to 0. Why I can use this formula? Because the matrices, both the matrices given are two cross 2 matrices. So here, what about it? Lambda square minus what is trace of A? Sum of the diagonal elements, it is 2 lambda. What about the determinant? 1 minus 1, it is 0. So that means it is equal to 0. That implies lambda is equal to 2, lambda is equal to 0 are the eigenvalues of this matrix. Now for corresponding to lambda is equal to 2, what will be the eigenvector? So what it is? From the diagonal elements, I have to subtract 2, 1, 1, 1 minus 2. This is nothing but minus 1, 1, 1, minus 1. So here, if I write this matrix into x1, x2 is equal to this matrix into x1, x2 is equal to 0, 0. So what does it mean? That means minus x1 plus x2 is equal to 0, or that implies x1 is equal to x2. So what about the eigenvector? 1, 1 is an eigenvector of A for lambda is equal to 2. Okay, next question is for lambda is equal to 0. That means from the diagonal elements nothing will be reduced. So this into y1, y2 is equal to 2. This is equal to 0, 0. What about the relation? y1 plus y2 is equal to 0, or y2 is equal to minus y1. So 1 minus 1 is an eigenvector for lambda is equal to 0. So I got both the eigenvalues and corresponding eigenvectors. So what I require? Now what is my S? S is equal to, what about the eigenvalues? The first one was, I forgot the eigenvectors. It is 1, 1, and second one is 1 minus 1. So what about my S? 1, 1, 1 minus 1. It is a symmetric matrix and its inverse can be comfortably obtained. So this implies, what about the S inverse? We know determinant is minus by 2. So minus 1 by 2, the elements are interchanged and these are made negative. So that is 1 by 2, 1 by 2, 1 by 2 minus 1 by 2. This is my S inverse. Now, what about my lambda? A is equal to, how should I write? S lambda S inverse. What is S? 1, 1, 1 minus 1. Lambda, it is lambda is equal to 2, 0, 0, 0 into, what is S inverse? Half, half, half minus half. So I got the factorization or of the given matrix. Now for the second matrix, for A is equal to, what was the second matrix? 2, 1, 0, 0. This is my second matrix. We know any triangular matrix has the diagonal elements as their eigenvalues, as its eigenvalues are the eigenvalues, are the eigenvalues. So what we get? So what are the eigenvalues of the given matrix here? It is a triangular matrix, upper triangular matrix. So what are the eigenvalues? The eigenvalues. So the eigenvalues of A are 2, 0. So for 2, what will be the eigenvalues? Matrix 2 means subtract 2 from the diagonal elements. It is 0, 1, 0, minus 2. This matrix for lambda is equal to 2. For this matrix, what about? So this is A minus lambda I. So A minus 2i into x is equal to 0 implies 0, 1, 0, minus 2 into x1, x2 is equal to 0, 0. That implies what? x2 is equal to 0. So here it has only one pivot, so another is free. So it is 0 and this is free variable. Here I can give any value. In particular I will give 1. So 1, 0 is an eigenvector of A for lambda is equal to 2. What is left? For lambda is equal to 0. For lambda is equal to 0, the diagonal elements will not change at all. So what I will get? The original matrix 2, 1, 0, 0 into y1, y2 is equal to 0, 0. So what about the relation? 2y1 plus y2 is equal to 0 or y2 is equal to minus 2y1. So what about the eigenvector? 1 minus 2 is an eigenvector of A for lambda is equal to 0. So I got all the eigenvalues, eigenvectors. So what should I do? So A is equal to the eigenvalue factorization is S lambda S inverse. That is equal to what about my S? It is eigenvector 1 0 at 1 minus. So 1 0 1 minus 2 into lambda is 2 0, rest all elements are 0 into its inverse. What is S inverse? What's the determinant here? 1 by 2. So what is the determinant here? It is, this is 1 by minus 2. It will be multiplied together into how much? Minus 2, 1, minus 1, 0. That is how much? 1, 1, 0, minus 2, 2, 0, 0, 0. This is 1. It is half. It is 0. It is minus half. So the eigenvalue factorization of A is this much. Okay. Now there is another question. What is the question? If A is equal to 4, 3, 1, 2, find A to the power 100 by diagonalizing A. Here there is an diagonalizing A. So how to do it? First we have to diagonalize. That means we have to obtain the eigenvalues and eigenvectors of A. So what we will do? The CH equation is whatever the characteristic equation, lambda square minus 7, 6 lambda plus whatever the determinant, 8 minus 3, that is 5 is equal to 0. So the eigenvalues are lambda 1 is equal to 5, lambda 2 is equal to 1. Now for lambda is equal to 5, what will happen? A minus 5I into x is equal to 0 implies how much it is? I will subtract 5 from the diagonal elements. Directly I am subtracting and I am writing the values 1 minus 1 3, 1 minus 3 into x1 x2 is equal to 0 0. That implies how much? So here reverse the relation. Minus x1 plus 3x2 is equal to 0, or x1 is equal to 3x2. So what about the eigenvector here? 3 1 is an eigenvector of A for lambda is equal to 5. Then we have to find out for lambda is equal to 1. For lambda is equal to 1, how much it is? Directly let me write 3, just 1 is subtracted from the diagonal elements. 1 into y1 y2 is equal to 0 0. So how much we are getting? That implies relation is 3y1 plus 3y2 is equal to 0, or y1 is equal to minus y2, or 1 minus 1 is an eigenvector of A for lambda is equal to 1. We got the eigenvalues and eigenvectors. That means we can write the factorization and we can find out the 10 to the power n. So here, as we have to diagonalize the given matrix, so lambda is equal to S inverse AS. Here, what is the first eigenvector? It is 3 1. Second eigenvector 1 minus 1. And what about A? A is 4 3 1 2. What about its inverse? You can verify the inverse is, it is S inverse. It is S 1 3 1 minus 1. Okay. So here this is equal to, what about this? Its inverse 1 by 4. 1 by 4. 1 by 4 minus 3 by 4. Okay, the portion are interchanged and here minus minus multiply and it is 1 by 4. So how much it is? So this into 4 3 1 2, this into 3 1 1 minus 1. Using calculator you can calculate, or you can observe that the value is 0 0 1. So this is the diagonalization of lambda A to get our value matrix lambda. Now what is our target? A to the power 100 is equal to S lambda to the power 100 S inverse, that is how much it is? S is 3 1 1 minus 1 5 to the power 100 0 0 1 to the power 100 is 1. And what about S inverse? 1 by 4 4 1 by 4 minus 3 by 4. This is 1 by 4. How much it is? This is after multiplication, it will give us 3 into 5 to the power 500 minus 5 to the power 100 minus 1 by 4. It is 3 into 5 to the power 100 minus 3 by 4. Then 5 to the power 100 minus 1 by 4. 5 to the power 100 minus 3 by 4. This matrix is our required answer. Okay. Now another question we will do, that is find out all. This is question. Find all eigenvalues and eigenvectors of a given matrix and write two different diagonalizing matrices. Okay. So what about the matrix given? A is equal to 1, 1, 1, 1, 1, 1, 1, 1, 1. It is given to us. What is expected? We have to find out all eigenvalues, eigenvectors, two different S1 and S2. These are to be obtained. Diagonalizing here S1 and S2 are called diagonalizing matrices. We are expected to find out two diagonalizing matrices S1 and S2. Answer. So what we will do? A minus lambda I determinant equal to 0 implies 1 minus lambda 1 1 1 1 minus lambda 1 1 1 1 minus lambda whole determinant equal to 0. But here we can see that the trace of the matrix is 3, and all 2 cross 2 matrix and 3 cross 3 matrix are of determinant 0. So it has two eigenvalues as 0 and one eigenvalue as 3. So we have got some idea. Now we will simplify it to get the roots. But it is just find out the determinant and let us equal to 0, that is 1 minus lambda whole square minus 1 plus 1 minus lambda plus 1 minus lambda, that is equal to how much? From here we are getting 1 lambda, from here we are getting 1 lambda, and 1 1 are getting cancelled. So how much we are getting? This implies this is equal to 0. So what does it imply? 1 minus lambda into 1 minus lambda whole square minus 1 plus 2 lambda is equal to 0, or that implies 1 minus lambda square plus 3, it is cube. 1 minus lambda cube, 3 lambda square minus 3 lambda minus 1 plus 3 lambda is equal to 0, or that implies minus lambda square 3 minus lambda is equal to 0. So the eigenvalues are 3, 0, 0. Okay, now let us find out the eigenvectors. For lambda is equal to 0, our matrix does not change. That means 1 1 1 1 1 1 1 1 1 whole is equivalent to R2 minus sorry, R1 stored in R2, R3 minus R1 stored in R3. How much we are getting? 1, 1, 1, 0, 0, 0, 0, 0, 0. So it is of rank 1 pivot. Okay, so what about the equation? So A minus lambda I into X equal to 0, lambda I is equal to 0 implies x1 plus x2 plus x3 is equal to 0 and x1, x2, x3. This is free, this is free. So 1, 0, 0, 1. So how much it is? It is minus 1, it is minus 1. So we got two eigenvectors. 2 Li eigenvectors of A for lambda is equal to 0 are, what are the eigenvectors? Minus 1, 1, 0, minus 1, 1, 0, minus 1, 0, 1. Okay, for lambda is equal to 3. What will be the eigenvalues? Okay, so now what will be the eigenvalues? Lambda is equal to 3 means the equation is minus 2, 1, 1, 1 minus 2, 1, 1, 1 minus 2 into, this is equivalent to 1 minus 2. Okay, let us write down first systematically. Control Z, Control Z. It is what operation we will do? Convert it into the echelon form. What are the echelon form we are getting? Here first I will do the row interchange. 1 minus 2, 1. What I have done? R2 interchange with R1. Then minus 2, 1, 1. It is 1, 1 minus 2. Okay, after doing the row interchange, but what is expected? Now I will make these two values 0. So it is 1 minus 2, 1. 0 minus 3, 3. 0, 3 minus 3. So now that is equivalent to, again, 1 minus 2, 1, 0 minus 3, 3, 0, 0, 0. Now, a minus 3x is equal to 0 implies, this implies we write here, this implies, get the equation y1 minus 2y2 plus y3 is equal to 0 minus 3y2 plus 3y3 is equal to 0. Here, this is a pivot, this is a pivot, so 1 is free, y1, y2, y3, which is free. Here I give value 1, from which I get this value is 3, and this value is 3 implies, and 3y2 is equal to 3. That means this value is 1. Now that here 1, here 1, substitute, it is again 1. So what we got? The eigenvectors y is equal to 1, 1, 1. So we got all the three linearly independent vectors. So therefore S is equal to, I'll keep my y at last and I will write two combinations. First eigenvector corresponding to lambda equal to 0, the eigenvectors I'm getting, I will write there. What are those? They are 1, 1, 1, minus 1, 1, 0. I got it now. Minus 1, 1, 0. Minus 1, 0, 1. And minus 1, 0, 1. This is one matrix. Another is S2 is equal to 1, 1, 1. First column 1, 1, 1. Second column is just interchange the columns. That is minus 1, 0, 1. It is minus 1, 1, 0. So I got my S1, S2, the two different diagonalizing matrices which were asked and I could do it. So with this, we should stop our diagonalization matrix process. In next class, we will discuss few more aspects of uh, complex matrices. Next class, we will start and finish complex matrices and the related problems. Thank you for your patience listening.